Lights, camera, action. Don't mind Mr. Chaplin, but have you ever seen an arc or an electric discharge, like a lightning bolt, jump between two metal objects? Or have you ever seen a static electricity balloon that sticks to a wall or someone's head? Well, then you're familiar with electricity. But how does electricity come about? Like, why does it exist? Well, in order to understand that, you have to go down to the very basic building blocks of matter, the atom. This is a model or a picture of an atom. And an atom is composed of these electrons. And you might hear the word electricity in electrons because those are very important because they are negatively charged. They're charged negatively. Now, in the nucleus of the atom, we have these neutrons. Neutrons are zero. They're neutral. They don't have any charge. And then we also have protons. And protons are positively charged. Now, charge is this fundamental nature of matter that results in electricity. So I like to think about electrons a lot because electrons are the essence of electricity. And that's because electrons are easily transferable. They're easily transferable, meaning they go from one object to another very easily, especially if that object is made out of metal. So I like to think about electrons a lot when I think about electricity. Now, some substances can transfer electric charge. For example, like a conductor, something made out of metal, is a substance that can easily transfer those electrons. An insulator, that's the opposite. That's a substance that does not transfer electric charge. The copper wire inside cables, that is a conductor, but the rubber tubing around those cables, that's an insulator. So electrons are not going to be able to move freely through those materials. Now, why is electricity so powerful? Well, I like to think about first something else that's very powerful, like the earth. The earth is powerful because it has it exerts this force of gravity. And that's because there's this gravitational field surrounding the earth, and that pulls on every one of us. Well, an electric force arises from an electric field, and these surround things like electrons and protons, things that have charge. And it just so happens that an electric force is way, way, way greater. It's way stronger than the force due to gravity. If you rub your head on a balloon, you can stick that balloon to the wall and it will balance the force due to gravity because of those little charges that jumped off onto that balloon, and now we have an electric force. So any charged object creates an electric field. Here's an electron, and here's a picture of the field that surrounds it. And a field is a region that surrounds an object carrying energy. And remember that energy is the ability to exert force, to do work, to cause change. So that electron there, it's surrounded by this field, and it can move stuff at a distance. You can come into the picture here maybe as a proton, and you're going to move because of that field. It's a non-contact force. Okay, so this proton and this electron, they're surrounded by an electric field. It's not drawn on there, but an electric field results in an electric force that can push or pull charged objects. In this case, it's a pull. There is There is a force of attraction between that proton and that electron. If you had two positive charges, they would feel not a pull, they would feel a push. They would feel a repulsion. Like charges repel. Unlike charges attract. Remember that. Now, here's the last thing. As physicists, we want to draw these things that we can't see. That's one of the pieces of modeling. And sometimes we model electric field lines. We draw them with like an arrow, and they always point towards negative charges, and they point away from positive charges. And so here are these two charges, a positive and a negative, and you can see the spread of the electric field because those electric fields actually interact. And those electric fields are going to cause a force of attraction between those opposite charges. Just know too that the more arrows means a stronger field. So there's sort of a greater density of arrows in this region versus maybe this region out there. So the field is stronger in this middle zone right in between them versus way out here. And that's all you need to know for now, but that is the basics to electric charge and electric fields.